Welcome to the deep dive. Looking at what you wanted to explore, it's really clear that in today's, incredibly complex digital world, securing our most sensitive systems and data isn't just important, it's absolutely paramount. So today we're taking a deep dive into privileged access management, PAM for short, which is really a cornerstone of identity security. And our mission today is to unpack how these cutting-edge AI technologies are changing PAM. We're talking about large language models, LLMs, application programming interfaces, APIs, and also this emerging player, the Model Context Protocol, or MCP.
That's right. And our goal here in this deep dive is to give you a clear, concise understanding of each of these. We want to get beyond just the surface level, maybe uncover some surprising facts, some nuances. We'll highlight the specific challenges, sure, but also the huge opportunities they present, and importantly, the actual business value they bring to making PAM frameworks better. We'll help you figure out what really matters in this very fast-moving landscape, so you feel genuinely informed.
Okay, let's unpack this then. PAM. At its heart, it's not just about security in a passive sense, is it? It's more like building a digital Fort Knox around your organization's most valuable digital assets.
Yeah, think of it as the ultimate gatekeeper. It's not just monitoring. It's actively controlling every single way in, every access point to your critical stuff, your most sensitive systems and data.
And you really can't overstate how critical that is, especially now with the kinds of threats we see. PAM is just essential for protecting against, both insider threats, where authorized people might misuse access accidentally or not, and also those increasingly sophisticated external attacks that go straight for the high-value accounts. It creates that really robust defense layer, making sure only the right entities, be they human or increasingly AI agents, get to sensitive resources. Okay, so let's dive into the first big player here. Large language models, LLMs in PAM. We're hearing about LLMs everywhere, but specifically here, they're AI systems built on those transformer architectures, trained on just massive amounts of text. And in the PAM world, they can do things like analyze user behavior, spot anomalies, maybe even give you natural language ways to interact with security operations. It sounds incredibly powerful, but in a system as sensitive as PAM, where are the biggest practical hurdles? Or maybe potential pitfalls when you bring in something like an LLM? What should listeners really be wary of?
That's a really crucial point, because while the promise is huge, you absolutely have to look at the challenges directly. Take data privacy and security. Now, this is a concern for LLMs generally.
Yeah.
But in PAM, it becomes extremely urgent. We're not just talking about personal info. We're talking about the keys to the kingdom, literally. A data leak here isn't just a breach, it's potentially catastrophic, especially, with many cloud-based LLMs that might, by default, process or even store prompts, and those prompts could accidentally contain privileged credentials or session data. That's a huge risk.
Wow, okay.
And then there's the more subtle threat of prompt injection risk. Imagine an attacker cleverly manipulating an LLM, maybe getting it to reveal a sensitive policy, or even bypass an access control decision just by hiding malicious instructions in a seemingly normal query.
So it could directly undermine the gatekeeper function.
Exactly. Then you've got the resource intensity. LLMs need a lot of computational power. For a PAM system that has to be on, always available, always fast, that means significant infrastructure costs and, frankly, energy use too. And think about bias and accuracy. If an LLM is making security judgments, but it learned from biased data or just inaccurate sometimes, that could lead to really critical errors, allowing bad access or blocking legitimate access. It's like asking a biased analyst to make critical security calls.
Yeah, I can see that.
And finally, just the integration complexity. Getting LLMs to work robustly inside existing, often quite complex, PAM systems without introducing new vulnerabilities. That's a serious engineering challenge. It has to work seamlessly with everything else.
Okay, so definitely a lot to think about on the risk side, but it can't be all downside, right? Where are the real aha moments for LLMs in PAM, especially given some of those challenges we just talked about?
Oh, absolutely not. The opportunities are genuinely transformative. For instance, behavioral analytics. This gets a massive upgrade. LLMs can sift through huge amounts of user session logs, historical data, not just for obvious red flags, but for really subtle deviations from normal patterns. That helps catch sophisticated insider threats or complex attacks that might otherwise just slip by.
Okay, so smarter detection.
Definitely. Then you have natural language interfaces. Imagine a security admin just ask, show me all privileged sessions for the finance server for the last 24 hours that came from outside the US, and getting an immediate, intelligently summarized answer.
That would simplify things a lot.
Hugely. It makes policy management, incident response much easier. They're also great at automated reporting. generating compliance reports, audit logs, but in human-readable formats, super fast, super accurately. That saves enormous manual effort. And for getting ahead of threats, LLMs enable truly proactive threat intelligence. They can process external threat feeds, news, vulnerability databases, and actually predict potential PAM-related weaknesses, suggesting fixes before an attack happens.
Now, something that's often compelling for organizations is the open source potential with LLMs. How do you see that playing out specifically in PAM? Thinking about vendor lock-in, customization.
That is a really powerful point and maybe sometimes underestimated. Yes, open source LLMs can mean cost savings. They can mean customization. But I think the real game changer, especially in security critical areas like PAM, is the transparency they offer.
Ah, right. Knowing how it works.
Exactly. Knowing precisely how your AI model is processing sensitive access requests. That gives you a level of auditability, a level of trust that you just can't get with proprietary black box models. And that's absolutely critical for compliance and, frankly, for peace of mind.
That makes sense.
So connecting all that to the bigger picture, the business value of LLMs and PAM becomes pretty clear. First, an enhanced security posture. That real-time, sophisticated anomaly detection drastically cuts risk from insiders and external attacks. Second, operational efficiency. Automation frees up security teams. They can focus on strategic work, not just getting buried in manual analysis and reporting.
More high-level stuff.
Right. For compliance, the automated intelligent generation of logs and reports directly helps meet critical regulations, GDPR, IPR, PCI DSS. Audits become much smoother. And finally, yes, there's potential for cost savings, especially with open source LLMs cutting down licensing fees. Though, as we said, you still have to manage those computational costs carefully.
Okay, so LLMs could really change how we detect threats and interact with PAM, but sort of behind the scenes, enabling a lot of this connection and automation, we have APIs. Let's shift focus to application programming interfaces and their role here. They're basically the language different software systems use to talk right, allowing PAM systems to connect smoothly with other key security tools, IAM, SIEM, maybe Microsoft 365, cloud services. They're really the backbone for automation and getting things to work together in PAM. But like any powerful tool, they've got risks too, don't they? What are the main security worries when it comes to APIs in PAM?
Oh, absolutely. The criticality of API security risks in PAM is huge. Think about it. A poorly secured PAM API could be hit with an injection attack. And that doesn't just steal data. It could directly give an attacker a privileged session token.
So direct access, bypassing normal login?
Precisely. It's not just about data exposure. It's about direct control over critical systems. Then there's the integration overhead. Connecting APIs across diverse systems, often older ones too, needs standardized protocols. It can be really time-consuming to make sure those connections are secure and don't create new weak points.
Okay.
You also have potential issues with rate limiting and performance. If you have huge numbers of API calls, which large organizations often do, you might hit latency problems or throttling. That can impact how fast and effective your PAM system is, especially when you need it most. Then there's dependency management. If you rely heavily on a third-party API for some key PAM function, what happens if that vendor has an outage or deprecates the API? That can seriously disrupt your PAM capabilities.
Yeah, being reliant on others.
Exactly. And finally, for APIs handling sensitive PAM data, there's compliance complexity. They absolutely must comply with regulations. That means strong encryption, secure authentication methods, and really meticulous auditing to prove data integrity and prevent unauthorized access.
Right, so a lot of vigilance needed there. But what about the flip side? The opportunities APIs unlock. How do they help PAM systems scale up, automate things in ways that really change the game?
The opportunities are vast, really. APIs enable truly seamless integration. They let PAM systems connect with IAM, SIEM, various cloud platforms, forging this unified, cohesive security ecosystem. Information flows freely but securely.
Creating a single pane of glass. Sort of.
Exactly. And for automation, they're indispensable. APIs can automate credential rotation, changing passwords regularly without anyone touching them. They allow for dynamic session monitoring and, crucially, enable just-in-time, or JIT, access provisioning.
Granting access only when needed.
Precisely. Only when and where it's absolutely needed. This dramatically cuts down manual work and the chance of human error. They also offer tremendous scalability. APIs let PAM solutions grow easily across hybrid and multi-cloud setups, handling dynamic workloads, remote access without performance hits. They facilitate real-time monitoring too, through that instant data exchange for tracking sessions, spotting anomalies. Security teams get insights immediately. And their ability to create a third-party ecosystem means you can plug in external threat intelligence feeds, maybe custom security tools, significantly boosting PAM's capabilities.
Okay, so lots of upsides.
Absolutely. Yeah. When you look at the business value, APIs deliver strongly. You get improved agility, automated workflows, integrations. They streamline PAM operations, allowing for rapid responses to threats or changing access needs. There's clear cost efficiency. Automation cuts down administrative work, lowering operational costs. APIs significantly boost compliance efforts by supporting automated audit logs and strong encryption, making it easier to meet regulations. And ultimately, they provide robust security by shrinking attack surfaces through real-time monitoring and secure integrations. Incident response gets faster, defense gets stronger.
Okay, so APIs are the connectors, the automators. Now let's talk about the newest player on the block, the Model Context Protocol, or MCP. You described it as an emerging standard, and it seems designed specifically to let AI agents, including those LLMs we discussed, interact securely with enterprise systems. So in PAM, MCP is about context-aware access control for AI operations. It feels really foundational, almost like the rules of engagement for AI in secure environments. But being new, what are the immediate challenges or risks we need to know about right out of the gate?
You're right, it is a frontier, and new frontiers, well, they always have unknowns. One big concern is the risk of spoofing and session hijacking, specifically during the MCP setup process. Imagine a malicious server tricking an AI agent into thinking it's talking to a legitimate system.
So the AI could grant access to an attacker?
Potentially, yes, if it's tricked into connecting to the wrong endpoint. It's also really important to understand that MCP isn't a full identity and access management solution by itself. It's a protocol for interaction. It needs to be integrated with other security components for things like token management, secure key storage, the whole identity lifecycle. It fills a critical gap, but it doesn't do everything.
Got it. It's one piece of the puzzle.
Exactly. And in complex setups, maybe with multiple servers using MCP, you can run into visibility gaps. It might be hard to track exactly what AI agents are doing without really robust, specific monitoring tools. If an AI acts unexpectedly, figuring out why and what it accessed could be tough. Being an emerging technology, there are also adoption barriers. It's not widely used yet. That means potentially limited vendor support, fewer experts available, maybe fewer established best practices to follow.
Makes sense. It's early days.
And finally, there's real complexity in policy enforcement. Defining those dynamic, context-aware policies for AI agents driven by MCP. That's tricky. You need sophisticated rules that consider what the AI is doing, its capabilities. And it's not simple.
Okay, so the challenges are definitely there, highlighting that it's still evolving. But the potential opportunities for MCP in PAM's future, especially as we think about managing non-human access, that seems huge. What excites you most about its potential?
What's really exciting is how it could future-proof security specifically for AI. MCP enables truly context-aware access control. This means policies for AI agents aren't just static, they're dynamic, based on the AI's current task or intent.
So much more precise permissions.
Incredibly precise, granting privileges based on exactly what the AI needs to do right now. It also promotes interoperability by standardizing how AI agents talk to systems. This means PAM can actually manage AI agents like first-class citizens right alongside human users within the same security framework.
Bringing them into the fold.
Yes. MCP also offers enhanced visibility. It provides potentially much deeper oversight, better audit trails of what AI agents are doing with privileged access. This reduces the blind spots that could emerge with autonomous AI. That's critical. It's also a strong enabler for zero trust principles. It facilitates just-in-time and least privilege access specifically for AI agents, which fits perfectly with modern security thinking. And finally, because MCP interactions are structured and auditable, it supports regulatory alignment with all the new AI governance rules that are emerging.
Helping organizations stay compliant as AI use grows.
Precisely. So the business value of MCP, while still emerging, feels foundational for secure AI. It offers future-proof security, getting organizations ready for safe AI adoption. It leads to reduced risk by enabling those context-aware controls and better visibility, mitigating threats like AI misuse or data leaks. It fosters operational trust because transparent, auditable AI behavior builds confidence in using AI for PAM processes. And that structured approach directly supports compliance readiness for AI-specific regulations, cutting down legal and reputational risks.
Okay, now this is where it gets really interesting, I think. To really get a handle on their unique power, let's compare LLMs, APIs, and MCP directly. Let's bring it all together and see how they stack up head-to-head in PAM identity security.
Absolutely. Looking at them side by side really clarifies things. Let's start with LLMs. Their primary strength: behavioral analytics. Think advanced threat detection, intuitive natural language interfaces, key challenges, data privacy concerns we discussed, and that risk of prompt injection. Maturity-wise, they're quite mature as a technology, but they are resource-intensive. They align best with anomaly detection, risk scoring, and intelligent reporting within PAM.
Okay, LLMs for analytics and insights.
Right. Now, APIs. Their core strength is automation and seamless integration. They're the connectors, enabling communication across your whole security stack. The main challenge: API security risks if they aren't properly locked down. Maturity: highly mature, very widely adopted. They align perfectly with workflow automation, real-time monitoring, and orchestrating access provisioning in PAM.
APIs as the workhorses, the integrators.
Exactly. And then we have MCP. Its primary strength is that context-aware AI access control governing how AI agents interact securely. Challenges: things like potential spoofing during setup and the fact that it's still emerging, so limited adoption right now. It's a nascent technology, limited ecosystem. Its best alignment is with advanced AI agent governance and enabling zero-trust principles for these non-human entities.
MCP for governing the AI agents themselves.
Precisely. Each has its distinct role.
And I think the real aha moment, like you said earlier, is often seeing how they can actually work together. They each have unique strengths, sure, and challenges, but the real power comes from combining them, creating something much stronger than any single piece.
And that leads us right into some strategic recommendations for you, drawing from what we've discussed. First, consider a hybrid approach. Don't bet on just one. Combine LLMs for that sophisticated behavioral analysis and threat intel. Use APIs for the robust automation and integration with your existing tools. And start exploring MCP for governing AI agents specifically. This gives you a really comprehensive PAM strategy covering human and non-human access.
Makes sense. Cover all bases.
And always, always prioritize security. That means robust encryption, strong multi-factor authentication, continuous session monitoring applied consistently across all these technologies to mitigate their inherent risks. We'd also suggest you start small. You don't have to boil the ocean. Begin with API-driven automation that's mature, offers quick wins in efficiency. Then, gradually integrate LLMs as your use cases become clearer. And maybe start piloting MCP for AI agent governance in a controlled way. This keeps things cost-effective and manageable. It's also smart to leverage open source where it makes sense. Use open source LLMs perhaps to cut costs and customize. And keep a close eye on MCP as it evolves as an open standard.
Stay flexible.
Exactly. And finally, maintain a strong compliance focus. Ensure all these technologies support detailed audit logging and help you meet regulatory requirements. GDPR, USPPA, PCI DSS, yes, but also those emerging AI-specific regulations.
Right, these aren't just abstract ideas. These are practical steps organizations can take to navigate this complex space and really level up their security. So, wrapping up, what does this all mean for you, the listener? We've covered a lot today: LLMs, APIs, the emerging MCP, all within PAM, from advanced analytics and automation to that really specific context-aware AI governance. The opportunities for better threat detection, much better operational efficiency, and genuinely future-proofing your AI integration, they're significant.
And by strategically combining these technologies, as we've discussed, organizations really can achieve a PAM framework that's robust, compliant, scalable, and one that maximizes business value while very consciously minimizing the risks involved. The future of security really is about intelligent, integrated defense.
So maybe a final thought to leave you with: as AI keeps evolving at this incredible speed, how might the very definition of privileged access need to expand to really encompass these non-human AI agents? And what new security ideas, what new paradigms will we need to invent to manage them effectively down the road? Something to think about until our next deep dive.